they are uh, they are always collaborating together. So I will give you a brief introduction regarding these separate topics. So first of all, what is open source contribution, and why version controlling crucial in open source contributions, and what is Git and what is GitHub? Those are the main questions that we are going to discuss today, and in advance, the Git and GitHub related things. So open source. So open source, from the meaning of the wording, open source means the source code is open publicly, and anyone can take the source code and make changes and contribute to those open source projects. So that's the meaning of open source projects, and any people can anyone can take the source code out and contribute to open source codes. So when it comes to collaborative working, and in the in the corporate world, it is very essential to work in a collaborative manner with others. So in that sense, um, we can't build a product, or we can't do a project without getting help from the others, or else without collaboration we cannot achieve those things in the corporate world. Even in university projects as well, we cannot do without collaboration anything. So same scenario in corporate world, it is happening in a very huge scale. So in that sense, version control comes into the picture. So from the name itself, version controlling version controlling is very crucial. So version controlling is uh, mainly essential for collaborative work, to keep track of the work we have done on the project, and also keep track of the others work in a structured manner. So uh, in collaborative world, we are basically considering the distributed version controlling. So version controlling is mainly for um, collaborate with others in any other countries, any other areas, anywhere in the world. We can collaborate with them and work together as a whole. So under the distributed version controlling, we consider mainly Git, or as the most popular distributed version controlling area is Git. So we use Git to keep track of the previous work and the others work, and our own work in a structured manner, with very structured backlog. So and also then we have GitHub. GitHub is a platform that allows us to like uh, achieve the things that we expect from the version controlling. And also there are some kind of icings integrated in the GitHub, and also there are some kind of same kind of platforms we are using in the corporate world. But in the sense, GitHub is kind of a most popular version controlling platform that we are using. So that's the main introduction of today's session. So let's get into the session. So before getting into the advanced topics that we are going to discuss today, so I hope that all of this audience is kind of aware of Git and GitHub related basic functionalities, like kind of getting things from a report repository, and making changes, and making commits, and pushing them, and pulling updates from the repository. That is the main flow, main life cycle. I think you guys are familiar with that level, familiar with Git and GitHub for that level. So anyway, we have some kind of most popular git commands. So git init, git clone, git add, git commit, push and pull. So git init, when you have a when you have a local directory, you can initialize that as a git repository. That means from that point onwards, we are going to keep track of the past of um, that particular directory. So in that sense, we can execute the git init command to make it as a git repository. So enforcing version controlling to the that particular directory that we are going to um, maintain as a git repository. So then we have git clone. Clone is basically to get the things from the, that means get a working copy of a remote repository in the sense, um, we have a repository hosted in somewhere, publicly accessible, uh, in a publicly accessible platform. So we are basically cloning, make a clone of that remote repository into our local machine to uh, do the things and do them, make the changes and implement the things uh, in the local environment. So we use git clone command to that. Then we have git add. So basically git add, uh, we used to after implementing changes, we use git add to put them into the stage uh, before committing them into the repository. So then we have the, again we have the commit, git commit. So git commit is the main way to uh, sending the, that means or else the updating the local repository that we are maintaining in our local environment. So this git commit is very essential, because when we commit a bunch of codes into a local repository, uh, from that point onwards we consider that chunk as a commit. So that chunk has a unique identifier. We call it commit hash. So we can identify that chunk of code as a whole uh, to many purposes. So in that sense, git commit is very essential and very critical. Then we have git push and pull. So basically git push is used to uh, send the uh, send the local commits to the remote repositories. So remote repositories again are the hosted repositories on some platforms. So then git pull again is to get the updates from a remote repository to a local repository. Okay. uh, those are the main those are the uh, basic functionalities of git and github, basically not github from the from git point of view. Those are the main functionalities of git. So I hope you are familiar with those things that we discussed in the previous slide. So let's dig into the advanced git features and git commands and the functionalities that we can achieve using git. uh, Again, okay. So in this diagram you can
Excuse me, Mr.
see
Dakshina.
yeah.
Before you continue, let me make a small interruption and remind everyone to ask questions using the provided Slido link. You can access it using the QR code shared earlier, or the link is provided in the chat. Sorry about the interruption. Thank you.
Yeah, cool. Okay. Yeah, again, if you have any questions, please put them into the link, then our moderators will direct them to me. Okay. uh, Back to the topic. So here in this diagram, it's kind of a complex diagram. So you can see the uh, main life cycle of a open source project actually. So when it comes to open source contribution or it shouldn't be open source actually. It can be any kind of corporate or any kind of uh, well maintained project. uh, if we want to contribute to that project, or else if we have to had to contribute to that project, we have to maintain this life cycle. So this is the best practice, that actually not a best practice, but it's a must, kind of a must to maintain when you are working in a in the corporate world, or else when you are collaborating with others for a common purpose. So in a kind of a higher scale. So in that sense, in this diagram, we will discuss all the things included in this diagram today. So basically forking, cloning, adding remotes, and creating and maintaining branches. We already discussed committing and pushing, and making PRs or else pull requests, and also getting updates from remote repositories using merge and rebasing, all of the things. So this is the main life cycle, and you will get a better understanding after this session what is the use of this life cycle. So basically in the according to this diagram, you can see all the things are, that means the flow is mainly originate from here. This is, we call this as upstream. So it is a upstream, it is an upstream. So this is the centralized repository, or as the mainly hosted open source project, or else the mainly hosted project in the GitHub. So we are basically making a fork of that repository to your local remote. That means what I meant by local report, uh, your origin, that means your, yeah, it can be um your personal GitHub account, or else it can be your uh, you are you maintaining under yourself organization, something else, or something else. You can take a fork from the um, main repository maintained by a third party in the corporate world from your company. In open source world, any open source host maintaining remote repository. So you can take a fork from that to um, your GitHub account, and then you have to clone that. That means this is basically, this origin is the basically your working copy of the actual open source project. So then you can take a clone of your origin, clone from your origin to your local machine to make the code changes in your local machine. So that is the main flow. So some people are maintaining this to the other way as well. So they are directly taking the clone from the um, upstream, or else the centralized one, and uh, they are making pull request to their origins, and making again sending them back to so sorry, they are directly cloning the upstream, and then pushing things into the origin, and again making pull request to the upstream. So the best practice is to forking the forking the upstream to your local. That means forking the upstream to your origin, and then cloning it to your local machine. And uh, let's say you are going to again create a that means implement a new feature on that huge repository. So for that, you are making a branch. You are basically making a branch in your local machine, and you are implementing all the things that you are going to implement under that particular feature. Then you are committing your new changes using the git commit, and then you can basically push your changes to your origin. So in this point, at this point, you cannot directly push things to upstream, because this is hosted by someone else. Sometimes you don't know who is the actual host of this project. You are just contributing to the open source project, no? In that sense, you don't know who's that, or you don't have any administrative permissions to pushing things to that particular repository. In that sense, you basically pushing and making changes to your hosted your hosted repository. That means the fork of the original repository in your local account. So after you pushing changes to your local, that means your origin, you can uh, make a pull request. You can make a pull request, we call it as pull request. That means you can so in that sense, you are creating here a branch. Let's say that branch is branch A. So you are committing things to branch A here, when you are working locally. Then you push the branch A to your origin, branch A to origin. So from the branch A, you can make a pull request to the original, very original repository. So you can send a pull request to the very original uh, repository, and then the authorized parties from that open source project, that means from that particular organization or somewhere, they have assigned some kind of committers, who can directly commit to this repository. So they can go through your pull request when that you are sending from your origin, and approve or decline that pull request. So once they approve your pull request, your local changes will be synced with the actual repository, or else the actual open source project, or else your corporate project. So that is the basic life cycle of uh, open source contribution or working in corporate repositories. So here you can see I missed that central arrow here. So this arrow basically to get the updates. Let's say you are working on a feature for couple of months. So during that couple of months, uh, will that original repository not change during that whole period? No, right? Because that is an open source project, same as you. Other people will taking clone of that project and making changes using going through this life cycle and making pull requests, and they may or may not be uh, merged into this central repository. In that sense, you have to get updates from that central repository to a local branch. Taking updates from your origin is not suitable, right? Because no one will making changes to your origin other than you and your team members or someone else, right? So actual thing is, anyone can make changes to the upstream or as the actual project. So the common practice is to take the updates from the original branch, so that means original repository. So to take the changes from the original repository, we can use kind of uh, merge or rebasing or that kind of a mechanism to get the updates. So that's the basic life cycle of a open source contributor, or as a basically a software engineer. So when we are working day to day, we follow this life cycle when we are implementing things. I think I'm clear. And if you have any questions in this life cycle, it's very essential to understand this. Please drop your questions in the given link. Okay, let's move on. So we just before this slide we discussed the life cycle. Then we have the topics that we saw in that diagram. First of all, we have forking. So I told you guys that forking is basically to what? To get a working copy of a to get a working copy of a publicly available, or else a corporate project to your personal GitHub account, uh, or to your or into your organization, one of your uh, organizations. So that's the main use case of forking. So since this is a hands-on session, I think you guys can also follow these things with the sample repository given by the organizers. So I will also show you how to do these things in GitHub as well. So okay, here this is the repository that has been given from the organizers to you and to me. So here you can see in GitHub, when we open the repository, you can see it's CodeJam by CSC, and the repository is secure code game. So you can see the repository here. And then what we were talking about forking, right? So here we can make a fork, basically make a fork by clicking on this. So you guys can also follow me with this. So as I mentioned, you can basically take a fork to your local GitHub account. In here you can see my local account, or else to one of the uh, one of the organizations maintained under yourself. So you can basically take use any kind of a name here. I will keep it as it is. And here you can choose whether you need only the main branch, or else you need all the branches from the remote repository. That means from the original repository. Let's say this is the open source project hosted by CodeJam by CSC organization. So I don't know who's the owner of this project. So basically going to get a fork of this to my local account. So I untick this to get the all the branches of this remote repository. So I'm basically creating a fork here. So yeah. Okay, so now you can see the URL has been changed. Now here you can see my personal username, and then secure code game. So this is basically my fork. So from here, next we can make a clone of this. So we will discuss that. So basically forking is to get a working copy from the publicly hosted repository. So next we have branching. Before getting into branching, let's clone this. So from here you can clone this using HTTPS. So basically copy this command from that button, and then open a terminal anywhere you want. So I have already created a folder called CodeJam, and then you can usually git clone. In my machine I have installed some kind of an extension. So in that sense, I have to tell this to you, otherwise you'll be confused. So instead of typing git, I can basically just type git. Okay, so that means just type g. So I usually follow that way. So when you are following these commands, always type git instead g. Okay, so I hope all of you have already installed git in your local machines. Okay, git clone the thing that we already copied and present. So you can basically clone the repository. So again, I prefer idea. Okay, I opened it in IntelliJ. So if you have some kind of ID like IntelliJ or VS Code or something, it's better. When you are coding, it's very easy to do all the things that we want using this kind of IDs. Okay, so here we go. We have this now. This is the cloned repository to my local machine to make changes locally. And we are following the diagram I initially showed to you. So let's quickly go back and see. Now I have forked and cloned it successfully to my local machine. Okay, so now you can see here, this is IntelliJ. So I think you guys have been notified to install VS Code. Same thing, when you open up this project in VS Code, it's totally okay. You can go to a terminal from the VS Code, and you can see the you can you can execute the things from anywhere inside this repository. Okay, so Next, uh, we are going to talk about branching. So, talking about branching, as I mentioned in the very first slide, branching is very essential because in your local working copy as well, it's better to maintain the main. That means the, let's say, main is the branch uh, where the actual product uh, hosted. That means in a managed service, let's say main is the branch which we have already directed to the service, or else if it is a product, main branch is the branch that we are going to build a new version of the product. Okay, so basically the main branch is the one containing all the changes. That means all the features implementing for a particular release or particular update. Okay, so in that sense, making changes on top of the local main also is not good in this kind of projects. Rather doing that, you can basically create a separate branch and make the changes that you want. That means you need to identify a clear cut that you are going to implement. Let's say like you are going to implement a new feature. Okay, you are going to implement a new feature. For that, you can create a new feature branch. Okay, so let's say you are going to create feature called X. So for that X feature, you can create a branch called X feature. Okay, so in that sense, you have a clear cut to implement in that particular branch. So in that sense, branching is very essential. So when you are branching, when you are working in branches, it's very easy to collaborate with others as well. Okay, so when you want to create a new branch, you can basically, so here I'm at the main branch here. You can see from here, and in VS Code you can see from this bottom bar as well what is the current branch that you are in. So uh, you can use basically git checkout to check out a new branch. So if you want to create a new branch, you can add a flag dash b. So again, if you have any doubts in these commands, just type dash h. Okay, so then you can find this kind of a uh, this type of a help tab. So here you can see what kind of things that this command support. Dash b, and then let's say this CodeJam one. Okay, here we go. We have created a new branch here called CodeJam one from the main branch. So I created the branch. I typed the git checkout command. That command on top of the main branch, right? On top of the main branch. In that sense, we command it to create a new branch from the main branch. So all the things included in the main branch up to that point will be directly copied into this CodeJam branch. Basically, a reference is going to this CodeJam branch. When we hit a git log, you can see CodeJam 1 and main is main are at the same level. So yeah, I hope you can understand. If you have any questions, please ask. Okay. Now we have created a new branch here. That's the way you are going to create a new branch. Okay. Um, okay. Next we have merge conflicts. So I think it's too early to discuss about merge conflicts. So anyway, I will give you a brief intro to merge conflicts. So uh, w- when you are collaborating with others, um, you have version controlling and Git and GitHub things, right? So in that sense, you can smoothly work with others, right? So you can smoothly work with others, but not that smooth. Okay, so not that smooth because let's say you and your colleague is working on the same project, and you both are giving arguing back and forth on a on the same file. And you say like, when you want to increment something from one, you have to use uh, variable name plus plus. The other one says like, don't use that, use variable name plus equals one to increment something from one. So you both prefer those two ways. So you both add that lines for same line from both sides. So in that sense, uh, git git will confuse what to choose, because git has no intelligence, right? So nowadays git has intelligent, but they it can't resolve it by its own, right? By its own. So in that sense, it will pop up a conflict, right? Okay, here there is a conflict, I cannot directly combine you both changes to main branch. What should I do now? Git will ask that question from your side. Okay, so in that sense, you have to figure out what is the conflict and what is the correct one to include here, and change it manually and resolve the merge conflict. Okay, so we will make a merge conflict later on and try to solve it. Okay, so next we have stashing. Yeah, stashing is also very essential thing when you are working uh, in a git repository. So let's say you have implemented thousands of codes for a feature, right? So for a feature you have implemented thousands of lines. So at the same level, you have to you someone will come and ask you to, I have implemented that feature in on that branch, so can you please check out to that branch and test it if it is working properly or not for me. Okay, someone will come to you and ask that question. So how can you, so you are under the process that implementing your own feature. You have already implemented thousands of code lines, and you have some more to implement as well. So in that sense, you can't commit your changes into a that means you cannot directly commit your changes to your current branch. uh, but you have to check out to that branch and check his or her feature as well. So how you achieve that? So for that you have a stash. You have a stash in your git repo. Okay, so that stash you can use basically hitting git stash. You can temporarily put them into a stash and check out to the other branch and check the do the needful and come back and unstash the changes to your own repository. Or as let's say you have to move the changes to one branch to other branch. You can easily do that using stash, right? You can basically stash your local changes and check out to other branch and unstashing them to that branch, right? You can do that locally as well. So same as stash, you have a shelf as well. So shelf is basically using to keep some kind of permanent things like, you if you want some configurations, you can put them into a shelf, and when you want them, you can unshelf them and use them. Stash is some kind of a temporary place that you can put them temporary for the use cases like I explained earlier. Okay, next you have git status. I think you know this. Git status is very essential before like committing or uh, pushing things to remote repositories. So when you have a visualization like in IntelliJ or VS Code, it is not that necessary. But when you are directly working in the command line only, it is very essential, because in the uh, uh, in the IDs, you can basically from the Git section, you can see all the changes here, changed files, and if they are staged or not. Also you can see in the VS Code Git section, and you can basically commit them using commit messages from the UI as well. Here, when you are working in the command line, Git status is very informative and very essential before committing them, because before committing them, it is very essential to know what are the things that we are going to commit, right? What are the things that we are going to add or stage. So it is very essential, hitting Git status and see the things that we are going to commit. Okay, then we have Git remote, right? So in the very first going back to the very first diagram that we showed to you, so in there I explained that when you are working in a collaborate project, you have to take updates from the original project, right? In that sense, you have to add remotes, right? You have to add remotes and maintain the remote repositories to get updates from that remote repositories, and also to the other side as well, to push the changes to remote repository. So let's let's see here, uh, hitting git remote dash v, git remote dash v, hitting git remote dash v, you can see the remotes that already there. So basically origin is the one directly creating from the git side. So that's the origin repository. That means the working copy forked from the original repository to my local account. So in this sense, to complete that diagram, I need to add a remote, right? I need to, first of all, I need to add a remote as upstream, or as when I go to the when I go to the this picture, you can say this is the upstream, right? So we have to add this upstream as a remote to my local branch, so the local remote repository. So to do that, you can basically git remote add upstream. Upstream, let's go here and again go to here and copy this. uh, okay, copy this and again go back to the IntelliJ and paste this here. So this is the command git remote add upstream. Upstream here, the sense you can say anything here, right? If you want to add any name, you can add that name here. You can you have to add any name here, and the link of that https link here to the remote repository. So okay, so again I will hit git remote dash v. So here you can see now we have two remotes, origin and upstream correctly. Okay, uh, so now I hit git fetch upstream to take the changes of the upstream to local repository, but not adding them to the code base. Fetching fetching things from upstream, not getting all changes and integrating them to your code base, but only taking the upstream changes as a chunk. And then if you want to apply those changes on top of your local code base, you have to use a git merge or rebase kind of a thing. Okay, we will discuss them in the future. Okay, so we were talking about git remotes. So we have added the remote added the upstream as a remote to get the updates from the original repository. Okay, so this is the, we are slowly completing the life cycle of a git project. Okay, then we have github issues and pull requests. Okay, um, okay, let's talk about GitHub issues at that point. So when we are working in the corporate project or else open source project, so you can see there is a separate tab there, um, called issues. When you get into a repository, you can see there is a tab called issues. So in the issues tab you can see the issues opened up by customers or open source contributors or someone else to your um, to your project, or else to the open source project. So you can open up these issues and see what are they mentioning, and if you have any solutions to these issues, if or else if you can resolve these issues, you can follow the open source life cycle, and you can assign this issue to yourself, and you can basically figure out this problem from the code perspective, and you can make a pull request as I mentioned earlier. So we will discuss about pull request at the from the couple of side later. So basically git issues are created to report bugs and request features, and request features and suggesting improvements for any kind of things. You can use a git issue. So when you are dealing with GitHub, you can basically create new issues by clicking on this. um, Here you have in this repository we have implemented like report a security vulnerability or a blank issue. When you go into blank issue, you can add a title, very brief and descriptive title, and then you can describe your title. um, you can describe your title in a very detailed manner. And also when you are going to report a bug, it's better to add a section to add a separate topic here, like reproducing steps, description, something, explain here, and steps to reproduce. So you can basically add some kind of steps to reproduce your bug. So when you work in a um, open source project, it's better to follow that kind of structure, because the uh, steps to reproduce is very essential when you are reporting a bug. So steps to reproduce, and then if you have versions of your project, better to mention the version. Okay. Those kind of things. So you can add those things, and this is the title, and then basically you can create. Okay, so when you create an issue, you can see that under the issues here. Okay. Okay. There's typo here. Okay. um that's the way to create issues. So issues are very essential in open source project and corporate projects to track the bugs and feature requests and improvement requests and things. That is very essential to keep track of the work done by others as well. Okay, that's all about issues. So we have added things here regarding issues, how to create issues. I'll demonstrated it already. Yeah, then we have the other thing, the pull requests. So GitHub UI in itself, you can see the pull requests here right after the issues. So when you go into pull requests, you can see the pull requests made by the people. So here I have made a pull request a couple of hours back. So add shipping feature. So this is the topic. So when you see that, you can see there is a product to calculate something and or something. So this guy has added a new feature to uh, consider the shipping things as well. So when you get into a pull request, you can see this kind of a structure. So this is the pull request description. So here it is a very little one, but when you are actually working on a project, it's very crucial to include the things that you have implemented. So in that thing also you have to follow a structured way. So basically first describe the problem that you are going to solve, right? Not just pointing out a issue and so this resolves this, not without saying like that. You brief it out at the in the pull request itself. You brief it out. So there was a bug in that version. From that bug you cannot do this kind of things. So uh, I have fixed that bug from this pull request. uh, in that manner you can describe it. And then most importantly you can see describe your fix, right? You can describe your fix, how you achieved that reported issue, right? How you implemented that, how you solve that. You have to say that as well. So you have to explain the fix as well. Then if it is a UI change or else the UI improvement or something, it's better to it's always better to add the UI diff to the UI diff means the difference of the UI that you have made to the pull request. Okay, so here we have some kind of workflows run here. So we will discuss about workflows in the later slides. Okay, that's all about pull requests.
Thanks, Mr. Dakshina.
Yes.
So far, the session has been really informative, and we have a few interesting questions in the slider. Shall we
Ah,
address them and move on to the
yeah, yeah,
next
yeah.
portion?
Okay.
Okay, sure. Uh, okay. We have a few common questions from beginners as well. We'll address them towards the beginning, towards the end of the session. For
Okay.
now, there are a few interesting questions about the things you talked about. So, okay, here's one. When pulling to the main branch from a sub branch, how to make sure how to make sure someone has not edit the main branch such that it clashes with your one. I think that's about branching.
uh, Actually the question is not clear. Anyway, when you are pulling things from a remote repository, you are pulling things to your local repository. So your local repository in the sense you are the only one who changing your local repository. So you are applying changes from the remote repository means uh, anyone can making changes to that remote repository, and you are basically getting changes, getting all the updates of that remote repository. We regardless the things that they change, you are taking the things from that remote main branch to your local branch. So your local branch is a private one. Private one means only you are the one maintaining that repository, and you are the one only making changes to that branch. So you can ensure that you have done changes to that branch, or you don't have any local changes to that branch. If you have local branches clashing with the others uh, from the remote repository, you have to resolve the merge conflicts if it raises any kind of merge conflicts. That's the way.
Thank
Anything
you.
else?
We have a few more questions about. There's one about Git stashing. So, in a team project, is it better to use Git stash, or can it lead to confusion if not managed properly?
No, again no. So when you are using git stashing, uh, git stash is also a personal one. Personal one means not to personal to a set of people. It's only personal to your local machine. So when you are stashing things, your stash will not share with anyone else. It is personal one. It is a personal one for yourself only. So you are working on a project, right? As I mentioned earlier, considering my example. So you are implementing a thing on your local machine. At that point someone come and ask to, can you please check this out or something. can you check out to this branch and see whether it is working properly or something. In that sense, you are quickly stashing your current changes to a stash, and then and then you check out to his or her branch and do the needful and come back to your local branch, come back to your branch and again stashing. In that sense, let's say like this, if you are stashing things to your stash, and then you are checking out to their branch, and you are going to unstash your stash to that branch. So in that sense, there can be conflicts, right? Because they have made changes on their branch. No, we don't know them. So when you are going to unstash your stash, there it may lead to merge conflicts, right? That's the way. If as long as you are working only on your private branches, nothing will happen. When you are going to collaborate with others branches, then only you have to worry about conflicts. I think
Okay.
it's clear.
Let's address one final question for now. There's this another question. If I'm working on multiple projects, how do I handle them properly through the terminal?
um uh, I didn't get you.
So there's this question asking if someone is working on multiple projects, how do
Multiple
they
projects.
handle them? Yeah, through the terminal.
If they are working on multiple projects, they can basically open up them on different IDs. So they can basically, you can basically, let's say you are working on th- 2 or 3 repositories. So in the corporate world, you have to uh, work in massive number of repositories. So in that sense, you are basically switching among the repositories, right? So you can in IntelliJ you can basically work like switch back with the other repositories from here, and any kind of ID you can switch to among the uh, projects or else repositories that you are working. So you have to follow the same life cycle that we showed you earlier in the beginning slide, uh, from in the all the repositories that you are working. That's the way. So I'm demoing here considering only one project. So when you want to switch among the projects, it's very easy, you can do that.
Okay.
Okay.
Thank you, Mr. Dakshina, for answering the questions.
Okay.
And I think we can continue the session.
Okay, let's continue. uh, okay. We were talking about pull requests. So I think I'm clear with pull requests as well. So basically pull request comes into the picture when you don't have committerships, or when you can't commit to a particular repository. It's very essential to make pull requests to that particular remote instead, directly committing them to the that repository. Let's say like in this diagram also, you are making changes in your local repository, right? In your local repository, local branch. So you are basically sending them to some kind of a remote, no? So in that sense, origin is also this kind of a remote. Origin is same as this, no? So in the oh sorry in the idea you saw, there are no remote dash v. When we hit git remote dash v, you see here there's no difference between the origin and the upstream. The only thing is you cannot push things to this thing. That means you are not allowed to directly. You can try that locally from this secure code game as well. So when you are trying to directly push to upstream, it will not allow. It will not allow to directly push things to main branch of this remote. But you can push anything, you can make any changes, you can also delete the whole implementation of this project uh, from your origin. But those changes will not reflect on the original project. That's the case. Let's say this is an open source project. So if it is an open source project, you can take this source code to your local repository. So you can take that and you can basically delete these things, right? So let's say you delete the main file. So if you delete the main file, if it is reflect on the actual repository, so it will lead to many problems, no? So in that sense, you are not allowed to push things to the original repository. Instead, you can push things to your working copy of that original repository in your local GitHub account. Okay, so that's the case. So so that there should be a way to uh, append the changes that you made locally to the remote repository, no? That means to the original repository, no? That is for that we have pull request, right? For that we have pull request to integrate those changes in a controlled manner. You are just opening up a pull request. The committers means the people who are responsible on that code. So open source contributors are not responsible people, right? They can do any changes, they can make any mess on that code, right? But the committers are kind of privileged persons, people on that particular organization. Let's say CodeJam by CSC is the organization. So CodeJam by CSC, there are some kind of committers. So they are responsible on that secure code game repository. So they will thoroughly test your pull requests and integrate them to the system, right? Integrate them means adding them to the main branch. Okay, so that's the that's the need of this life cycle actually. That's the need of this life cycle. I hope I'm clear. Okay, we discussed about pull request as well. So here we have how to create a pull request. Let's create a pull request little bit later. uh, Okay, then write quality commit messages. So when you are working on your group projects, you have to commit things, no? So in that sense, when you are committing things, you are not that much worrying about commit messages, no? You will sometimes you will keep it blank. You will type some kind of test, some kind of uh, set of letters, or just fix this, just fix for the implementation, just add this kind of things, no? So but maintaining quality commit messages is very essential when you are working with unknown people, or when you are working with the huge teams. Okay, so because the committee is the one chunked all the chunk some kind of a unique set of, that means clear cut of code is integrated in a commit. So you should have a capability, you have to have a capability to identify that clear cut and integrate it as a commit with the proper commit message. That's the need. That's the need. So better to follow a present tense kind of a thing when you are writing commit messages without implemented this, added this, removed this from this, or using that. It's better to use present tense as a corporate practice. So we usually use present tense. So and also it's better to start with the verb. I add this, or remove this, fix this problem, kind of things. Then if the code is kind of a confusing one, it's better to explain the thing that you do. That means the if it is algorithm, this I use this algorithm, using this algorithm or something, adding. It's better when you have a complex or messy code. It's better to explain the thing that you did from couple of words. So and also that message shouldn't be that long. Okay, so it's not better to add a very huge message as a commit message. It's also not a good practice. So here you have some kind of examples, right? Let's say this update files, no one can understand this, right? They surely understand this, but they will understand you have updated something, but they will don't know get any informative things from this commit message. But instead doing this resolve checkout crash when item quantity exceeds stock. It's very informative, right? It's very informative. And here they have followed uh, some kind of a standard here, right? Adding something here and a colon, fix card colon, and the thing that they did. So this following this kind of templated commit messages is also very good. Okay, that's all about commit messages. So we have git cherry pick. Okay, we have next git cherry pick. Before get into this topic, let's do something here. Okay, we have learned so many things so far. So let's go into a file. So please follow me and do the changes that I'm doing here. Try to do them. uh, okay, so let's go into this file. So here you can, this is a git ignore file. Git ignore files are very essential. Okay, and most importantly, when you are working on IDs like IntelliJ or VS Code or something, they will internally create some directories like .idea. This .idea directory created by the IntelliJ idea. So IntelliJ ID, they create this thing. So when you don't have git ignore file, so here I added git ignore idea. So since I have added this to git ignore, that will not initialized as a index as a git, git git related files. So it will ignore that. So when we make changes to these files inside this, uh, it will not consider. Okay, so git ignore is another essential thing. That's why I wanted to tell. So let's go into this file, and we have already created a branch from the main branch. So we are in that branch now. So let's make a change here. Okay, let's get the suggestion from the copilot. So we have made a small change, right? At this to this. Okay, so basically now we have changes. uh, let's hit a git status and see what have been changed here. So you can see I have modified the source main file. So let's say we have integrated the shipping functionality to here. Let's say, yeah, let's say we have integrated the shipping functionality here. So now let's basically uh, try to add this to the stage. I hope you can see my commands. So these are the commands that I'm executing. So try to follow them. Git hitting its status, you can see the uh, informative details about the file modifications. So git add dot means add all the things to the stage. So stage is a intermediate state between committed things and changed files. So stay when we add things to stage, those things are indexed and are ready to commit. So only things are added to the stage will commit, others will remain as change files. Okay. When you again hit git status, you can see now this is green because they are added to the stage. Okay, now we are ready to commit. Now we are ready to commit. uh, we can basically git commit dash m, add shipping feature, let's say like this. Okay, and shipping feature is the commit message. So follow the structure that I have followed. So git commit, instead g you have to hit git git commit dash m, the message that we are going to uh, label here. So and hit enter. Okay, you can see the changes have been synced with the branch. So in the UI also you can see this change is uh, included in the branch as a commit. So you can see here I have changed that when you are taking a git blame. Okay, so let's hit the git log here. Now you can see when you hit a git log, you can scroll down to see the all the changes. So you can see at the CodeJam 1 local branch, no, I named it as CodeJam 1 local branch. You can see at shipping feature commit that I uh, just made here, and you can say there is a difference between the main branch and this branch now, right? At the main branch you can see this shipping feature, but at the code jam 1 branch you can see the commit feature, I mean shipping feature. Okay, again when you go into git log you can simply press q to get out from that. Okay, press q to get out from that. So let's basically um, uh, go to the main branch, and that means check out to the main branch and see. Let's see, as you can see here, shipping feature is not there, right? Shipping feature is not there. When you go check out to the shipping code jam 1 branch, you can see the shipping feature. That's the way you implement that. Okay, now we have committed the new thing to my CodeJam 1 branch, but still you can't see those changes. Let's say let's go to the origin. So this is my origin now, but in the at the origin you cannot see the things that I have changed, right? It's not loading. The thing I wanted to emphasize is like I have made changes on top of this CodeJam 1 branch, right? I have locally created this branch and I made some changes on top of that branch, but still I haven't pushed them to a remote, right? Git remote dash e, I haven't pushed them to a remote, any remote, right? To the origin or to the upstream, right? If I want to, my internet connection has been dropped, I think. Okay, anyway, so when you want to update the origin, you have to use the git push origin. Origin means the remote. Remote means the name that I have added to the remote, as the remote. And then you have to mention the branch name. Here I have added CodeJam 1. If I want to, so in by executing this command, uh, if my origin doesn't have the branch called CodeJam 1, it will create the CodeJam 1 branch on the remote origin and appending the changes to that branch. If it is already having a branch called CodeJam1, it will update the branch. So if you have already having this branch, and when you are pushing this change to that branch, if there are any conflicts with that branch, it will raise a merge conflict again. It will not allow you to directly push them. So in that sense you can use dash f flag to force push to that particular branch. So in this sense, this particular uh, scenario, in my origin there's no such branch called CodeJam 1. Okay, so what has happened to this? I'll reload it. Okay, okay. At that point my origin doesn't have such branch, so we can basically hit that. And also when you want to change the name, that should be reflected on the origin. That means I have created the branch called CodeJam 1, but it is not branch name is also should be informative. Okay, in that sense you can change the name like this. So you cannot directly call the git push origin shipping feature, but you have to follow this convention to ask them to uh, push the changes on the git jam code jam 1 to the shipping feature branch. Okay, so in that sense, okay, now you can see here, you can see code jam 1, right? Code jam, yeah, code jam 2 is here, code jam 1 is not there. Now when I press enter here, all the changes are reflected here, and you can see in this notice as well. So here you can see that shipping feature branch. Okay, so in your main branch, when you go to the main python file, you can't see the shipping feature here still, right? But when you switch to the shipping feature branch, you can nicely see the changes that we have made, right? When you go to the again back to the code and see the commit history, you can see the add shipping feature commit that we have already made. So as I mentioned, you can see, right, you can see here there is a unique identifier for this, right? We call it commit hash for that particular commit, as I mentioned earlier. Okay, so please follow the things that I am following. At the end, I would like to see some kind of PRs from you guys by adding the shipping feature. Okay, so then this will give you some kind of informations here. By clicking on this link, you can directly go to a PR creation, that means pull request creation window. Instead doing that, let's go to the shipping feature branch here, switching to the shipping feature branch. So in the URL you can because in the corporate world we are using this URL to manipulate this URL to go to places, go to branches, go to repositories. So slash tree slash branch name that you want to go. So here up to this point the repository, then slash tree slash the branch name that you want to switch. Okay, so go to there, and here you can see a contribute button. So from there you can hit the create pull request. So then it will show the ability to merge, if it is able to directly merge, or if there are conflicting things with the main branch, it will say that, right? It will say that. So let's say while you are doing this thing, someone come and edit the same line, same thing, and add here like text or something. So in that sense, you will end up with the merge conflict. So you have to resolve that when you are making a pull request. So if you can do that on this GitHub window, you have to do it locally and make another commit to the same branch. So, and also when you are creating a pull request, you are not directing a commit to the original repository. Instead, you are opening up a path between two branches. Okay, you have to clearly understand that. You have to clearly understand, I am creating a path between shipping feature branch and the main branch at the CodeJam by CSC. CodeJam by CSC is some kind of a organization. In that organization, in that particular secure code game repository, to the main branch, we are creating a pull request. That means we are opening up a new path from the my local secure code game repositories shipping feature branch. So when we are adding anything to the shipping feature branch again and again and again and again, those things will be reflected in this pull request. Okay, until the pull request is closed. When the pull request, when the pull request has been closed, um you can still add things to the shipping feature, but those things will not reflect at the same pull request. So the common practice is whenever you m- uh, merge the pull request to the main branch, better to delete the branch. That means better to delete the shipping feature branch, because the opened up path from this pull request is already merged and closed, no? So in that sense, no point to add things on top of this, right? So it's better to close that branch. Okay, so as we discussed earlier, there should be a very descriptive, that means very informative and very straightforward title here, uh, to the product. Let's add the description: adding consideration for shipping in the product, or something. uh, Fix or the implementation details and new parameter for shipping, and consider it for the cost, or something. I don't know what actually does here. Okay. So this kind of thing. So when you are dealing with MD files, so that means markdowns, you have to follow this syntax. When you're using hashes, you can make them as topics. So you, when you want to add bullets, you can like add no add dashes, uh, kind of things. Okay, so when you want to mention some kind of commands, you can origin shipping feature, so that kind of things. So these kind of syntax you have to follow. You can take them from the documentation. Okay, now we are good to create the pull request. So when you are creating pull requests, you can create draft pull requests, or else you can create a direct pull request. So let's say we have configured some kind of workflows for test running and linting. So in that sense, you can, while you are implementing the feature, you can make a draft pull request, and instead testing them locally, you can make a draft pull request, and uh, draft pull request to the original branch, and run the workflows and get informations and fix them back. Okay, so here let's click on create pull request, and then it will open up a pull request. And here again, merge is blocking, and merge is blocking because here we have added a rule here for this particular branch. Is branch is secured. I will show them. And again, you have seen here uh, this run workflow here to run the tests, as I mentioned earlier. So still we cannot merge this until some committer come and review this pull request and accept them. Okay, so from this point you can approve the pull request and submit. Here I can't approve my own pull request because it is not not intuitive, right? So some committer can come and review this pull request and approve that. After approving, we can merge the pull request. So are there any committers here? Can someone come and approve this pull request? Okay, let's allow them to review, give them some time to review this and approve. During that period, let's get back to the presentation. Okay, so up to this point, we have created a new pull request. So please follow my steps and try to make a pull request to, by implementing the shipping feature to the CodeJam repository. That means secure code game repository from your end? Okay, I can see some pull requests from your end. I would like to see pull requests from all of you there. Okay, so we were discussing about committing things and best practices there, and then we have some kind of more advanced topic here, git cherry pick. So when git cherry pick comes into the picture, uh, this is actually uh, very rare very rare use case of git functionalities, when we don't need to work with uh, many remotes. Okay, so let's say okay, let's take an example like this. So we have two repositories. Clear Carefully listen to me. So we have two repositories, but they both have the same set of code. Let's say like this, they both have the same set of code. So why do we need to maintain two separate repositories? Let's say like this, those two repositories are maintained for two different purposes. Let's say repository A is a open source repository. Repository B is the same code base, but it is a closed one. That means it is not open source code, but it is a closed source one. Okay, so let's say we are using that closed source repository for giving pro features from a product. From a product point of view, we are using repository B to give the pro features of that particular product. Repository A is a open source one. It will only give the basic functionality of that particular product. Okay, you are experiencing such things now. If you want to get the pro features, you have to subscribe. Some All of the time, all the web apps will ask for subscriptions, no? So let's say this is a product. Branch A is maintaining open source things, and their functionalities are very free. So branch B is a closed source one, and it's offering some kind of pro features to gain money to that particular company. Okay, so let's say uh, by the time that they will need to take that some kind of old pro features to their open source code base. Okay, so let's say like shipping feature is that we added just before. Shipping feature is a pro feature. Okay, so then they need to get that shipping feature from repository B to repository A. Okay, repository A. After few years, couple of years later, it will normalize. That shipping feature will be normalized. Then they decide to get that uh, into the open source code base. So in that sense, they can add the shipping feature branch as a remote from the remote repository B to repository A. So using Git cherry pick, you can cherry pick that particular commit by giving the commit hash. Okay, I will show the command for that. So basically GCP, no, no, Git cherry pick, like this. Git cherry pick, and then you have to add the commit hash. Okay, commit hash. But when you go to when you are when you are hitting enter after adding the commit hash here, it will not getting the shipping feature to this particular repository. Okay, the reason for that is that particular commit is persisted in the repository B. Repository B is shipping feature branch. So we have to add the repository B as a remote prior to execute that command. Git remote dash v, let's say, let's hit git remote dash v, and here you have to add another remote, git remote and cp branch, cp repo or something, and then you have to add the repo b here. Okay, repo b here. Then you have to fetch the things from the repo b. That means fetch the things from the cp repo, and then only you can basically hit the git uh, cherry pick and the commit hash. Okay, this thing. Okay, so let's quickly check out to the main and uh, GCP. Oh no, Git log and let's say like here you can't see anything related to shipping feature, right? Here also you can't see anything related to shipping feature. So, but let's go to here and get the shipping feature from here. Okay, let's g cherry pick this commit hash. I can directly add this to this branch because all this commit hash is already there in this local environment, because it is a separate branch of this particular repository. Okay, so if we are going to get the thing from the same repository, you don't uh, worry too much by adding remote separate remotes, but you can easily fetch the things from upstream and easily cherry pick that to your branch. Okay, so I have cherry picked the thing. So you can see here the shipping feature, and when I hit git log here, you can see the shipping with the commit message. You can see the commit here, but the thing is commit hash will be changed. Okay, commit hash will be surely changed because commit hash is a very unique one, no? So that particular commit hash is unique for that particular branch, this commit hash. So the commit hash persisted here will be surely changed. Okay, so that's kind of an advanced thing here. So we are basically using cherry pick to get things from separate remote, not from separate branch, but from a separate remote. Okay, so we basically get that. Okay, next we have what we have discussed about cherry pick and git squash. We are using git squash to avoid unnecessary commits basically. So let's say we have to you saw that test running workflow, no? Once we are making the pull request, we have to the workflow will change, and we have to uh, make the code changes, make the code changes to make it as make it correct to run the test correctly. Or else let's say the committers come and add some commit message, that means add some comments on the changes you have done, and you have to fix them out prior to merge the changes to the main branch, right? So in that sense you have to make couple of more commits, right? Couple of more commits before getting merged the shipping feature. Okay, this git squash is very essential. Squashing things is very essential. let's say like uh, let's say like I have implemented the shipping feature here, no? I have implemented the shipping feature. Arid? Okay, use case of the shipping is use case of the squashing is this. So by clicking on the git blame, you can see you can see a commit here at shipping feature. Okay, so let's say some committers will come and ask me to change this thing to using using separate variable and assign it, and make this more clear or something. They will add a commit. comment. So I will again come here and make changes and again make another commit and add fixes to shipping feature and push it to the same PR. Okay, then once the feature is getting merged, so later on, let's say after a decade later, someone will come and hit a git blame here, and in IntelliJ I can get a blame like this. VS Code you have to take it in a different manner. Okay, and hitting on this, and they will see, okay, here this line is from adding shipping feature. So okay, now I found out the adding shipping feature commit. So this is basically a commit, no, not a pull request. Okay, this is a commit. So I just found out the commit, and now I can go to this particular commit and track out all the things related to the shipping feature. Okay, so let's click on this and see the thing. And I will see like adding changes to the shipping features, or fix things on shipping feature. Then they will then the one who come after the decade later will confuse, right? So I have added one commit to add shipping feature, and then there is a fixing comment again. There can be huge number of commits on top of that to implement the shipping feature. So so that how can I find that? I have to go there and again find the PR and analyze all the things from that. Now I cannot track it locally now. So avoiding that, you can use basically git squash before merging the changes to main repository, main branch. You can basically squash the commits and add a descriptive and add a informative commit messages for that implement shipping feature or something, and uh, merge them with the main branch. That's the use case of squashing. So again, we have git rebase and git merging. So I discussed earlier at the very beginning. On top of that diagram, when we are when we are working on the open source life cycle, it's very essential to get regular updates from the original repository, right? The common practice I use actually, whenever I'm working on let's say I'm working on a feature for a couple of weeks. So in that sense, whenever in the morning, whenever I'm going to start work from on my feature, before starting work, I will take the updates from the remote repository. That means from my upstream, right? So there are a lot of updates from the upstream every day, right? So we have to take them before starting that day work. Otherwise, we have to worry too much about fixing conflicts with other scores, right? In collaborative codes, we don't know what they actually implement. No, we only know the things we implemented, right? So in that sense, fixing merge conflicts is a headache actually. So avoid that. You can take regular updates from the upstream, right? So when you are taking updates from the upstream, you can use rebasing or merging. Let's say pulling or rebasing. Those are the main two things that you can use. Okay, so one thing is rebase, the other one is merge. So you can merge the upstream main to your local branch, or else you can rebase the upstream main to your local branch. So these two seems to be at the end, these two will end up with the same result, but the way they perform is totally different. Okay, you have to take a very good knowledge about merging and rebasing. So I also took a very long time to get the clear understanding between rebasing and merging. Okay, so when you are rebasing things, basically it's very essential to rebase things when you want to maintain a clean main branch, or else when you want to maintain clean branch as a separate thing, and you can apply your changes, your all local changes on top of that. Okay, so that means, let's say, considering the timeline, on the main branch, you have separate the main branch from here, and you implemented many things there, and at that point main branch is also getting updated with separate things. Okay, so when you are rebasing the main branch to your feature branch, so main branch will remain same without a single change to the timeline, and all the things included in your feature branch, that means all the commits added to your feature branch, will be applied on top of the commits on the main branch. Okay, on top of the main branch, on top of the changes on the main branch. So this is no longer a timeline. This is no longer a timeline when you are rebasing thing. So the con of rebasing is, it will break the timeline, and also it will change the commit hashes of this particular commits. So let's say this is mapped with this is mapped with this, but the commit hash is different now. This commit will disappear, these two commits will disappear. Instead, create two new commits with new commit hashes on top of the current changes of the main branch. So these will remain same, these will not getting changed, but the changes made in your local branch uh, will uh, will apply on top of that with new commit hashes. Okay, but you don't need to add the new commit when you are rebasing thing to your local branch. That's the very that's the pro of this rebasing thing. That means when you want to get the updates from the main branch, you can basically rebase, and if there are any conflicts, like let's say, like from that point and that point, you both are working on the same file, and uh, you guys are making changes to the same line. Okay, same set of lines. In that sense, it will make a conflict. You have to figure out the conflict and resolve the conflict while rebasing. Once you rebase the code to your feature branch, it will not create any more commits. It will not create any more commits. You can say maintain the same set of commits without conflicts, but the commit hashes are changed. Okay, no more commits, no more merged commits coming into the picture. Okay, so and also this history is very readable. This history is readable in terms of features. In terms of features or branches, this history is very readable, and it is a very linear one. It is a very linear one. No branching. It is very linear once you rebasing things to a single branch. Okay, so it is very linear, and it is chunked depending upon the features, and you can very easily read them, but it will surely break the timeline. Let's say you implemented this on January 1st. Let's say on the feature main branch, this part is implemented on March 1st, but your January 1st thing will come after this now, to make it linear. Okay, so it will surely break the timeline. Okay, let's say, like, merging or pulling. So when we are working on projects, we are regularly use pull, no, git pull. So in that sense, git pull means first fetch things and then merge. Okay, first git fetch from the origin, and then merge things to the local branch. Okay, so that's the difference between merging and pulling. Okay, here we are comparing merging and rebasing. So when we are comparing merging and rebasing, so that's the as I mentioned on the rebase thing. So when we are merging things, it will not make a linear graph like on the rebase. There are some kind of branches. This is the feature branch, and then when we are when we are integrating them together, let's say, like we are getting updates from the main branch to the feature branch. In that At that point, it will create a new commit message. Okay, it may create a new commit message. It will not always creating a commit message, but it may create a new commit message. Okay, it may create a new commit message. So that's the difference between rebasing and merging. So and also this will surely maintain the clean timeline. Okay, this will surely maintain the clean timeline in terms of time. When you are considering things in terms of time, better to always use merging. When you are considering things in terms of features or the chunks of codes, it's better to go with rebasing. Okay. Okay, that's the main thing that I wanted to discuss on that part. So shall we move to some questions quickly?
Okay, Mr. Dakshin, we have a few interesting questions since the last Q&A session. So, uh, one question is, have you used tools that enforce commit message formats? And would you recommend them for student teams or competitions?
um, what commit
So,
message enforcing tools?
yeah, yeah.
uh, Actually I haven't, but
Okay,
that is basically um, that means that is basically you can follow them depending on your organization actually. So when you are working on an organization, if that organization follows some kind of standards or templates for commit messages, you can follow and also you have to follow the um, that particular that particular template of the commit message. And also when and also you can do that. um, and also I think you can do that using GitHub Actions as well. As I can remember, we can enforce some kind of templates for the commit messages from the GitHub Actions as well.
okay. Thank you.
Yeah,
So,
also I think Prettier plugin is also supporting some kind of commit messages, enforcing things.
okay.
VS Code Prettier plugin. Yeah.
Yeah. Another question we have is, how can cherry picking affect the readability or cleanliness of a project's commit
Um,
history?
yeah, nothing will change. So it will add as a fresh commit. And if the previous commit is a very structured and readable one, you can basically basically maintain the same thing. And also I will demo the resetting things later on, and at that points you can see like that here. Now when we hit git log, you have the same commit message I have added to the other branch. No, so if you want to change the commit message, you are always open to change them. You can basically do that. And on the timeline on the timeline point of view, it will it will surely add as a new commit.
Okay. Thank you, Mr. Dakshina. Those were the questions, the new
Okay,
questions we had since
cool,
the last time. So we
cool.
can continue.
Okay, let's move on. So okay, okay. Now we are going to talk about the undoing things in Git. So undoing things in Git is very essential. Let's say mistakenly we do some kind of things, and we some mistakenly add something to the stage. We mistakenly commit something. We mistakenly push something. We mistakenly merge something to the main branch. So at any point we can revert, but at some point we cannot erase the history. We cannot erase the history, but still we can revert anything, roll back anything, get back to the previous state, anything. But the history will be there at some point. After a certain level, you can erase them from the history as well. Okay, so undoing things in Git is very essential. Okay, this is actually not included into the undoing things, but to fixing commits you can use amend flag. Okay, so you can be when you have already committed something, let's say like whenever we go to the CodeJam 1 branch, you can see here git log. Okay, at shipping feature. So here uh, if you want to make any change, +1 or something, I don't know, this is not intuitive, but we will change like this. So git add dot status, and if you want to add this change to the shipping feature, but you don't need to add a new commit for that, in that sense, you can basically add things to your last commit. Okay, add things to your last commit by hitting git commit dash dash amend. Okay, at that point you will it will pop up a window to change the commit message itself. Okay, so we have already added this as the add shipping feature. No, add shipping feature, at that point it will ask you to, if you want to change the commit message, or do you need to continue with this. Okay, if you want to continue with this, you can press you can basically shift colon qa. Okay, shift colon qa and press enter. Shift colon qa and press enter to save that, and then when you clear that out and get again git log, and you will see no new commits, but the thing that I have added is already added to the previous commit. Amend is used for that. Okay, amend is used to uh, edit the last commits, manipulate the last commit. Yes, again, if you want to unstage the changes in the stage, you can use the git restore with the dash dash staged flag with the file name, and then it will restore them from the stage to the unstaged level. Okay, then again we have um, unmodified modified file, basically the rollback. So you can use the raw restore without any flags with the file name, then it will discard the changes permanently locally, and history will also clear. You can't revert back that changes into the picture. Okay, so when you are executing these commands, you have to carefully do them, because you haven't commit them or push them to somewhere, no? Push them to a origin or somewhere, no? In that sense, when you are restoring file, it will lose all the changes you have done so far. Okay, so you have to be aware of that as well. Okay, that's the basic thing of restoring. So then as I mentioned earlier, commit is a chunk of codes, no? Chunk of codes of chunk of files, no? Bunch of files, no? So in that sense, you can take out a file from that commit and revert that commit back, revert that particular file only from that file to some point back at the timeline. Okay, I think you got me. That means you can basically take a file out from a commit. That means you can basically get open up a file, and you can travel back in time only on top of that file, not totally from the commit history, not totally from the commit history, but only from the that particular file. You can use git checkout commit hash that you want to travel back. That means, let's say in the timeline you have to go back to here. So if you add the commit id here, commit hash here as this, and dash dash path to the file, it will it will direct your this particular file to the up to this particular level. That means after this particular comment, that means after this particular comment, we have added changes here, no, adding shipping feature and things, no. So those changes will be lost. Those changes will be saved as uncommitted changes from that particular file when once you hit git checkout commit id to the file path. Okay. Okay. Next. Okay, next you have a git revert command. You have a very safer way to revert things, even though the things have been already merged to the main code base. You can use git revert, mentioning a particular commit id, so those changes from that particular commit id will be erased. That means erase means that we that will create a new commit to reverse back the changes done by that particular commit. Okay, not permanently reverting directly. Instead, it will create a new commit to revert back the changes done by the previous commit. Okay, so in that sense, your timeline will be more cleaner. That means not cleaner, but very informative, and you can easily track the changes you have done so far. And with the mistakes that you have done, if you use git revert with the commit id. Okay, git revert with the commit id. Okay, uh, that is another way to reverse back the changes you have done. Again, you have another interesting thing, git reset. So when you are resetting things, you can you have three options: hard reset, soft reset, mixed reset. I think by default it git support hard reset. When you when you directly I'm not sure about that, because I have changed that on my environments some time back, I think. When you are resetting things with hard flag, uh, your changes will be permanently lost. Okay, you cannot get them back if you don't have them on a separate branch or on the remote repository or somewhere. Okay, when you reset things with hard flag, when you reset things with soft flag, only those changes, that means only it will it will move back in time up to that particular commit hash. But all the changes after that particular commit will be stored as staged changes, will be stored as stage changes as mentioned here. Okay, then when you use mixed approach to reset, it will go back in time for a particular commit, up to particular commit, and the changes done afterward from others as well will be remained as unstaged, when will be remained as unstaged. So I'll demo that. Let's hit git log here, and let's say we want to go back in time here. So okay, I think you got me. So when I copy this commit hash, I'm going to go back to that point before that means the before adding the shipping feature. Okay, so reset commit hash again. Then we if we want to do this permanently, you can basically uh, add the flag hard. If you want to keep the things as unstaged, you can use soft. If you want to keep them as unstaged changes, you can use mixed. I will hit mixed, and then it will change to this point. And you can see whenever you hit git status, you can see these things have been um, made as unstaged, because the color is red now. So and also when I hit git log again, you can see no commit messages with the add-in shipping feature, right? Add-in shipping feature. So in that sense, I can again uh, add all, and again git commit dash m at shipping feature. Now you can again see git log. After hitting that, you can see again we have the at shipping feature. Okay, so that's why I told. So we were in the main branch, no? So we were in the main branch, and when we are in the main branch, let let's again hit, oh sorry, git log again. So here we cherry picked this, no? Here we cherry picked this, no? So in that sense, after right after we cherry pick that, sorry, git log, right after we cherry pick that, we can reset it, soft reset it to that point. Okay, again let's hit this to see whether the changes are there or not. Now the shipping feature is not there, shipping feature commit is not there. Okay, and also uh, status, and you can see now this is green, right? Now this is green because I hit we hit the reset command with soft. Okay, so in that sense you can see that that as green, that means those changes are staged. Okay, those changes are now staged. Why I am doing this? To address the question you asked before. Now you can again commit this, again commit this in the main, this kind of a commit. Okay, now you can manipulate the commit. Okay, so I cherry pick things from other branch, and I I reset it to manipulate the commit message. Okay, reset it to the previous commit, that manipulate the changes. Let's say we want to add some more changes to the shipping feature, then also you can reset back them and add more features, and also you can use the amend command instead. I hope you I'm clear there. I think that's all about undoing things. Now let's we have to move to the automation thing. I will brief this topic as well here, since we are running out of time as well. So here we are going to discuss about the GitHub Actions. So GitHub Actions are basically as I mentioned at the very beginning. So before getting to this, I will quickly go back to the first picture. So here, okay, we have discussed all the things here. Okay, so we forked the repository, we cloned it, and we added remotes. We added remotes as the upstream as the remote, and origin was already there as a remote. And we created a new branch, and we worked there, and we commit, and we push, and we work around, work with the commits and the undoing things and the amending and all the things. And we from the origin we created a pull request, and then during we are working, we discussed how to get the updates from the upstream using rebase and merge. So we know now how to use rebasing and merging. At That means where you want to use rebase, where you want to use merge. Now you know, you have a clear idea. And then at the meantime, let's say like uh, where my shipping feature, okay, my shipping feature PR is get merged, right? So here there is a committer from the CodeJam by CSC. So he has already merged my PR to the merge my PR to the main repository. Okay, so whenever now you go to the main branch of the original repository, in the source code, in the main Python file, you can basically see the uh, shipping feature that I have implemented. Okay, shipping feature that I have implemented. Okay, so someone else is also added that same feature. Okay, and there you can see this cannot basically cannot basically directly merge. Okay, it says like this branch has conflicts that must be resolved. Okay, at that point we come up with the what conflict. Okay, so here it will say like, it say like locally it has like, it say like uh, now there is a conflict, no? So there from that CodeJam 1 2 branch, from that particular user, it says like net minus equals item dot amount. Okay, this is not a best practice to implement these things, no? Because when you are assigning or doing these kind of operations, it's always good to make spaces between them. Okay, so in that sense, this is the correct way to do this. Okay, in that sense, you can do the changes inline here. That means after deciding what to keep, and you can make this as resolved and add a commit. Okay, this can done by the that particular user. Now now we can, there's no conflicts, we can basically merge this. Okay, whenever we are merging this, we have to now consider about squashing thing, because I have here added the new commit, no, added the new commit to commit before merging. That means merge branch main into CodeJam 1 2 means I merge the main or actual main branch, current main branch into the CodeJam 1 2 branch of that particular user by fixing some kind of merge conflicts, right? At that in that scenario, we need to worry about the uh, okay, we ask it to run the workflow as well. Okay, yeah. And at that point we can basically go to that go to the file changes, and now you can't see any file changes here because the same change is already merged from my PR, no? In that sense you can't see them. Now all tests pass, and now I can squash and merge this change. Squash and merge. Okay, from that point I can edit the commit message as well. Okay, now this PR is also merged. That's the workflow. So okay, merging the PR to the main to the upstream, we discussed now. So by that all the things here we have discussed. So now you know how to work in open source projects and how to work with uh, in the corporate world, and how you can collaborate with others when you are working on a uh, uh, working on that kind of a public repository. Okay, so I think we discussed all the things here, and then we have the latter part of our session today. So that is the GitHub actions and GitHub workflows. So let's say you are working on a project maintained by a authorized party, or else the maintained by a well-known organization, and when if they need, if they, so you are regularly, that means that particular organization regularly gets PRs and code updates from their open source customers, and that means from open source users, and also from their employees, and all the parties, huge number of PRs. So they can't, and also the code base is very huge one. They have a very massive number of code lines, and the code base is very long, and uh, they don't know what will happen if someone change a code line to some particular file. And at that point there should be some kind of mechanisms to analyze that those PRs up to some level, analyze that particular PRs up to some level. So for that, nowadays we have some kind of PR analyzers as well. So instead analyzing those pull req PR in the sense pull request, PRs by the committers of that particular organization. We can use AI agents to analyze the PRs and give feedbacks as comments. Okay, so when we have a PR, we can use some kind of AI agents like CodeRabbit or something. Um, there are a lot of agents like that. So they can we can integrate them through the GitHub Actions to analyze the PRs as well and giving feedbacks on them. And also, let's say we have uh, implemented the test well defined test suits to test the product by cross checking with the code base. So when we are when we are introducing a new change to the code base through a pull request, we can run GitHub Actions automatically to run the set of test files, as well. Okay, so and also as I resolved the conflict earlier, linting kind of things, that means coding best practices. Whenever assigning a value to a variable, you have to have two spaces before and after the equal sign. Those kind of linting things, that means formatting related things, you can follow them using GitHub Actions. You can enforce those rules to the given PR using a GitHub action. Not only for a PR, you can use GitHub Actions at any point of the life cycle when you are incorporating GitHub in your version controlling. Okay, so GitHub Actions basically for CI/CD, continuous integration and continuous deployment or continuous delivery, continuous deployment for the services, continuous delivery for the products uh, or any kind of integrated things. So in that CI/CD for DevOps, they basically use GitHub Actions. Very, very. They utilize GitHub Actions in a very massive scale to achieve their targets. So and automate things in the integration part, as I mentioned, linting things, code linting, formatting, and also running tests in the integration part, and continuous delivery or continuous deployment part to automatically deploy the things to their managed services on any cloud platforms like Azure, AWS, or Google Cloud Platform, or anywhere, and maintain their infrastructure using Terraform or something. They can use GitHub Actions. There are many more use cases on GitHub Actions, and basically, when you are dealing with GitHub Actions, you can basically GitHub Marketplace. They have already provided some kind of GitHub Actions from their side, so we can take them and basically refer to them. And also there is a very nice documentation for GitHub Actions. So when you are implementing a GitHub action, you can follow this documentation. You can just Google it and get it. So and follow that to implement the action. So right after the pull request tab, from a repository, you can see workflows. So when you go into a workflow, you can see the workflow history. And also we have already created the workflow here. as you already saw when you go into a go into a PR or else pull request, you can see there is a okay if it is already merged, you can see that there is a separate tab here too. That means there is another comment kind of a thing popping up here to run the GitHub action. Here we have defined. So whenever we go to the GitHub action definition here, inside the github folder, there is a separate folder called workflows. There you can create new YAML file to integrate a new GitHub action. So there we have to incorporate separate several things when we are dealing with GitHub actions. We have to concern about workflows, events, jobs, actions, and runners as well. Okay, what are they? Basically, workflows are the automated processes. Okay, like as mentioned here, run tests when code is pushed, link the code file according to the best practices of Python codes, link this code into the best practices of a Docker file. That means format the code if it is well formatted according to the Terraform file. Okay, so then we have events. That means the trigger of the GitHub action. In our implementation, we have used that event runs on, no, not the runs on, it will run on pull request to the main branch. Okay, it will run a pull request on to the main branch. That means whenever a pull request come to the main branch of the repository, it will run this following jobs. It will run all the jobs listed below here. Okay, so the name of this workflow is run tests. Then we have jobs as mentioned here below. So we can have several jobs. So here we have the test. Then we can also have a kind of lint, kind of anything you want add as a separate job here under this particular workflow itself. So then you have actions. So actions means the actions that we need to take in uh, that particular workflow. That means reusable pieces of code that help with automation. Okay, and then you must have a runner to run that particular code. That means to run that particular workflow, do you need to have some kind of a environment or a VM or something to run that particular workflow behalf of our site. So here, as you can see, these are implemented considering the uh, adhering to the documentation of GitHub actions. So we have implemented some kind of steps here. Check out to the code and then set up a Python environment, set up Python version 3, that means, and then install some kind of dependencies to run the test. And here we have not installed any specific dependencies, and then run the test file, right? So here we have run a command python -m unit test discover tests and test star python files inside the this test folder. Okay, that's the basic workflow that we run when someone make a pull request to the main branch. Okay, I think you get a brief introduction to the GitHub actions. GitHub actions is a very massive topic. We can talk couple of hours regarding this topic. I'm just briefing out this. So yeah, these are the things that I have explained earlier. Okay, yeah, when you want to implement a new GitHub action, you have to create a new YAML file, as I mentioned, define the workflow using triggers and jobs and steps, as I mentioned earlier, similar thing. Okay, so we are basically done with this. So regarding GitHub actions, you can create a new GitHub workflow from the GitHub UI itself. So it will create a new workflow git YAML file here for you. So let's say like we are going to get a Docker file thing here. So it will template. It has already templated for Docker image CI, Docker image continuous integration. So when you are pushing things to the main branch, when you're making a pull request to the main branch, it will run these jobs. So it will build on this Ubuntu VM. Steps are basically to build the Docker image, You can basically use this this add this workflow file, that means docker image YAML file into the .github workflows directory, and whenever this triggers comes into the picture, you can uh, this GitHub action will execute, and it will build the docker image that you have on that particular location. That's all about GitHub actions from that uh, briefing level. So here, as I can mentioned earlier, in their marketplace there are several, there are a lot of predefined GitHub actions, and also you can anyway follow the GitHub actions documentation when you want to implement a new GitHub actions. All the syntaxes are listed down here. When you want to do a task, you can basically follow this, or else you can easily ask a AI tool to create me a GitHub action file, YAML file for to achieve this particular task, and you can fine tune that with your knowledge and considering the GitHub actions documentation. Okay, that's basically it from my side. You can ask any questions if you have, or else we can wind up for today. Do we have any more questions, Nimesh?
So far, not any more questions. So
Okay.
we'll give them a chance to ask questions once again.
Okay.
Yeah, the Slido is shared in the chat. So if you have any questions, you can ask them. There were a few questions in general regarding to GitHub. Shall we answer those? So
Okay, what kind of questions?
right. There are some questions. So uh, here's one. What's the best way for a student to start contributing to open source projects, especially if they are not sure where to begin? So those kind of questions are from beginners, I suppose.
Okay. Uh, okay, it's a cool question actually. So whenever you need to contribute to open source, actually that question I also had that question from the very beginning. So when you want to collaborate with the, or else contribute to open source projects, first of all you should identify, that means you must identify what are your interests. So that means if you really like to work with some kind of a particular topic, then you can, it's very easy. So at that point you don't need to worry too much about what are the actually my interests, because whenever we are contributing for a open source project, so we are proactively doing that. No, we are not doing that for to get a mark from a exam, or because of a salary or something, or nothing. No, in that sense it must be one of your interests. That means the thing that you are doing there should be included in the set of your interests from your personal point of view. That's the first thing. So first of all you have to identify what are your interests in the open source world. Then again you need to consider from what point you need to start contributing to your interest. So you have to first gather some knowledge on your interesting areas, and then you can just google and search what are the projects that are currently running on the open source world, considering your interests. So whenever you google something, I interest this is my interest, and suggest me some kind of open source project. When you ask from a chatbot, it will say you can directly go with this and that, you have this, and you can try out this, and you can basically dig into contribute in that project after getting some knowledge from that project side, and then you can basically start contributing to that. First of all, when you are going to contribute to such project, basically those projects are very massive projects, no? So most of them, so basically first of all you have to set up their product locally on your local environment, and work around there, go here and there, click on the buttons that they have given, and identify what actually they are doing from that their project, and then you can start contributing to them. Okay, and also one other tip, you can trace back the previous year's Google Summer of Code projects, and the companies collaborate with Google Summer of Code GSOC, and you can get a very clear and better understanding what are the currently running projects, and what are the most common open source projects, and what are the companies offering very good and very um, well maintained open source projects. And also, so though if they are very that means very authorized and very standard projects, they should surely have Apache 2.0 or some kind of a open source licensing as well. So if they have that kind of open source, well reputed open source license, then you can trust them, and you can collaborate with them. And also you have to trace back their activities. If that project is not getting updated from decade, no point of contributing to that project. No one will look into your PRs, no one will approve them, and no one will merge them to their code base. So that project surely should be a updating one regularly. And also they should maintain very good versioning mechanisms, and they should deliver their product regularly, and they should have a very good community support through a Discord server or anywhere. So those are the considerations. Any more questions, Nimesh?
Mr. Dakshin, so there was one more question that's kind of related to that. So, there's a question about how to identify the right open source projects to contribute as a beginner. So maybe that's kind of related to the earlier question.
So I think I already answered to that
No,
question,
okay,
right?
yeah. Yeah. Other than that, there are no more new questions. So I
Okay,
think we can wind up the session.
yeah, okay. So
Okay.
I think you got some idea on the uh, Git and version controlling, and how to work with Git Git as a open source contributor. So yeah, that's all. Thank you very much.
So thank you, Mr. Dakshina. The session has been incredibly informative, and the practical demonstrations and the step-by-step walkthrough have been especially helpful in making these concepts clearer and more approachable. And that brings us to the end of today's workshop. And on behalf of the organizing team, I would like to extend our sincere gratitude to Mr. Dakshina Ranmal for sparing his valuable time and sharing such insightful, practical knowledge with us. Your guidance will no doubt help all participants to better prepare for the challenges of CodeX and future software development endeavors. And thank you to everyone who joined us for this in this evening. We wish you all the best as you compete, collaborate, and continue to push the boundaries of what you can achieve. And let me remind you, the first competition of Codex will be happening on 29th at 6 p.m. So see you all there. And I wish you all the very best for this coding endeavor. So have a great night and see you at the competition on 29th. Thank you.